Good afternoon, everyone. We are Team 5G Rapid Response. This is Joanne, Gavin, Yuching, Yuri, and Amrita. Our project is T-Mobile First Responders, and our project sponsor is T-Mobile. So to start with the problem we're addressing, in the past 20 years, students, parents, teachers have been facing the reality of school shootings in America. This map shows all the school shootings that have occurred in the past years. The worst record of school shootings have been in the past academic year, having 193 school shootings. The biggest problem faced during these situations is the police not being able to get accurate and in-time information about the situation, and also not being able to effectively communicate across teams and establish an incident command system. Hence, it is crucial that we address how we can improve the accessibility of information first responders use during active shooter situations in schools. So for our approach, we started with conducting research, and then prototyping solutions, and finally evaluating our prototypes. We conducted secondary research, analyzed the competitor landscape, conducted interviews and contextual inquiries with the 5 police and school departments. We came up with 3 core design requirements which informed our final solution, which is a 2-component solution including a web app and an image processing device. We then evaluated our prototype with 2 rounds of evaluations, iterated twice, and finally tested our final prototype for its accuracy of detection and its system functionality.
So our proposed solution may have 2 components. The first one is a rapid response maps installed in the classroom and will only be triggered after the school goes into lockdown. It will send all the live information on scene through the 5G service to the web app used by the first responder. So the rapid response maps will leverage 5G machine learning, computer vision, and count numbers of attackers, weapons, and civilians in the room. The web app will visualize all the information we got from the first component and also show the live video feeds of each classroom. And besides, it will help establish an instant command system. During our primary research, we interviewed the 12 police officers and visited 3 schools and available call centers for field research. Here are the key insights we got. So first, the police officers need to know if it's a barricaded or active shooter situation, and also they need to determine the hot zone, warm zone, and cold zone. So the hot zone refers to the area with the highest potential to be dangerous. After the police clear out area, it will turn into warm zone, and cold zone are the safe areas with no known threat. And also, our solutions would enable establishment of an incident command system. Besides, some students may have privacy concerns about installing cameras in the classroom. Based on all the insights we got, we made a rapid response. We made a rapid prototype and conducted 2 rounds of disability testing with 9 police officers and 3 fire captains. In the first round, we mainly tested that if our product is easy to use and easy to understand. And in the second round, some police officers requested more feature like the live video feeds and also the ICI click location. And also some police officers want to know the entrances and the surroundings of the school building so they can confirm the casualty connection point based on the map.
Here we have our hardware architecture. We have a trigger consists of 3 components, an ESP32, a button, and a battery. For our rapid response lens, we have our Raspberry Pi, a uninterrupted power supply, a custom PCB, a 5G hat, a NeoPixel, and the Luxembourg camera. Here is our software architecture. As you can see, our hardware sends data to our backend, which we use Azure for, and we have the Cosmos DB, and we run a Flash server. That will then send over to our web app, and our first responders will be able to see. Here is our video demo. Here you can see we're able to pan around the map, and we see a school that is in danger. We click on it. So you can see, we can pan around the school grounds and see what's happening. You see the classrooms are safe. We can set the ICS lead, which is the Incident Command System lead point, anywhere in the casualty point. We can also set different colors, warm as in it's semi-safe, and then cold, which is safe. And the red zones mean that it's not safe. So every zone in the school will automatically be not safe when there is a shooter in the school. Here you can see the live video of the school, of what's happening in the classroom. And you can set the zone colors and you can see the pure map. As you can see that there's four students, and you can see on there, you can see the count that's increase and decreasing as the students are moving here. Yeah, so like every time like teaching would lock Benita, the count would go down. If Benita is being seen, then the students' count will increase. And then in replace of a weapon, we use a banana detection. So when a banana is detected, you can see that there's an attacker, increased count. So then the classroom is in danger. And you can see that it's the classroom 103. So you can see here, the banana is being detected, the count is increased, and there is a danger.
Yeah, and here is our user journey map. So when the responder, usually the police officer, respond to the school shooting, you can go to our web app and check the school location. And after clicking the school in danger, you can check the other responder status and know if he is the first one arrived to the scene. And also he can sign himself as the ICSD or find the current ICSD location through the map. And then he can go to the classroom list to find where the shooter is and how many shooters. And also he can check our student number as 0 or not to know if the shooting center is barricaded or active shooting. The barricaded here means like the shooter is alone somewhere. If it is ICSD, he can set up the Zoom to be held one code and also the casualty collection point to notify other rescue team to transport the victims. Yeah, and for our prototype iterations, for our first iteration, we added the LED light to show the video recording status and also the live video feeds into our interface. And for our second iterations, we replaced our 120 millimeters fan to be 340 millimeters fan to reduce 30% of the hardware size. And also we use a more detailed floor plan with the outside without our view and the real-time alert icon.
Awesome. So during our research, we found that existing solutions fell into primarily one of 3 buckets. Either before an attack happened, where they're focused on prevention, before emergency response actually makes it to the school, which is focused on saving time or buying additional time. And then lastly, when the emergency responders actually make it to the scene, which is focused on helping those first responders take control of the situation. So looking at existing solutions in that first bucket for attack, a lot of these solutions are again trying to predict an attack happening, or they're trying to control, for example, firearms to prevent these situations from ever happening. Before the emergency response arrives, we have things like gun detection. These types of models unfortunately have a lot of false positives or misses altogether. And then we found actually that there was a complete lack of solutions that were focused on helping first responders once the attack actually came underway, which is why we decided to focus on this space. So our solution is focused on having a device inside the classroom. Currently, there are no solutions that focus on being in the actual classroom itself. We want to integrate with existing school lockdown systems. And we want to help establish the incident command system and we want to create a centralized source of information. From our business model, we worked on this project with T-Mobile. We know that T-Mobile has an existing sort of initiative to become an internet service provider with school districts. So we'd like to piggyback off of that and kind of offer a security plus internet access type of package. So that way we could leverage T-Mobile's expertise to help with the installation and configuration and overall maintenance of this product. With that in mind, we are going to be working inside school districts, so we do have to be aware of things like FERPA, which is the Family Educational Rights and Privacy Act, as well as COPA, which is the Children's Online Privacy Protection Act. With that in mind, we have a few mitigations that we've already worked into it. The first is an always-on, not recording approach to things. So our device is always on, but it's actually not going to be recording and saving that data, which should help alleviate some of the data retention and privacy concerns that we will have. The second is going to be controlled access logs, so we know who's accessing the system, what they're doing when they're inside the system, just to make it easier to sort of monitor and regulate that. And then, of course, in the future, if we were to develop this, we would be working with lawyers and data privacy experts to make sure that we're a little bit more robust. So from a hardware development standpoint, our big thing going forward is going to be focusing on a hardware redesign. Our existing hardware, we kind of like hit the limits of what we were able to do with it. Software, we would like to make our own proprietary models for weapon identification and gunshot detection. And then just for future development, we would like to come up with a way to integrate existing hardware solutions at the school. So special thank you to everybody at T-Mobile, the Tech Experience Hub, for all your help. And then also to all of the organizations and schools that helped make this happen. So thank you.
Great job, IGR. Comments, questions, feedback for our team? I have one question for you, when first responders are on scene, how are they accessing that information? What types of equipment or what tools are they using?
So currently inside squad cars, police are going to have access to like either like a laptop. Most of them are touchscreen enabled, or they will have a tablet. And so our plan is to just, that's why we're using a web app, so that it is something that they can use with existing hardware. Yeah.
How do you reconcile the fact that if there's an active shooter and they see an LED light on your device go off, that they'll know they're being recorded? And
Yeah, no, I think that's a great question. During our initial research phase, we worked with Eastside Catholic. And for example, in that school, when the school goes into lockdown, they have a message that plays over the school-wide PA that effectively says, hey, we're going into lockdown. They have different messages based off of the situation. The whole idea behind that was they wanted an attacker to know that they knew they were on the grounds. So kind of following that same logic, it kind of, for us, was two words. One, it told that our users, our students, our teachers that, hey, like the system's been activated. And two, we actually chose that route. We wanted them to know that they're being recorded because we've found out in research that that is potentially a deterrent.
Thank you. Any other questions or thoughts? Any comments on my John? Thank you very much, team. Next team up.